Good morning. All right, cool. Let's get started with attendance. Alpha. All right. Kadar.
Here.
Justin. Saw you. Sandro. Sandra? No. Sandra Dorstein? No. Okay. Aaron. Christian Fisher. Ooh, not doing as hot today. Jakylin. Calvin. Freddie. Matthew. Do you prefer Matthew or Matt? Okay. Donovan. Christian Johnson. Kadar Johnson. No, Kadar Johnson. John Massey. Jamel. Idris. John. Mark. Ross. Rashad. Zach. Nehemiah. Khalik. Paul. Isaiah. All right. I feel like we have more people. Yeah.
Yeah, I'm here.
Sandra. That's what I thought. I said it a few times. Yeah. Name? Christian. Yeah. Okay. Anyone else? Troy. Yeah. Okay. Does it show up on your class schedule? The class?
Yeah.
It does? Oh, okay. Good. All right. Maybe it just takes some time to update for me in Starfish, but as long as it's showing up on your end, then we should hopefully be good. And I'll go back and update Starfish once your name comes. All right. Anyone else that I missed? Okay. Name? Your name?
Oh, Nehemiah.
Nehemiah. Okay. All right. Going forward, I'll be a little bit stricter on tardies, so try to come in by 11. Cool. Save. All right. Let's get into it. Happy Friday. Cool. So today we're going to move on to the next concept, which is operators. If you remember when we were first learning about data types, there's a diagram that said like we're going to start off with values, then we're going to go to expressions, and then we're going to go to statements. Today is the day that we transition from just the pure data types and variables to actually using those variables in expressions and being able to do stuff with the data. So overview for today, we're going to be doing some advanced topics on variables, closing that out. Then we're going to do a debug challenge where I have 5 examples of faulty code, and I'll have you all try to figure out why the code is faulty. There's a lot of subtle errors, and I think we'll very closely match the type of problems that you'll see on the upcoming midterm exam. Then we'll go into arithmetic operators, and then finish off with string operators. Any questions before we get started? Okay, let's do it. All right. Does anyone remember kind of the 3 main things that define a variable? Yeah. So.
It's uniquely named.
Okay, uniquely named. Sweet. Can someone give me a second one? Holds, yeah, generally holds some sort of data. So references a memory location that stores data. And then the third one.
Storage location.
Yeah, so kind of tied into memory. And then the third one I kind of added onto like the original definition is that value can vary or change. So again, uniquely named. We use lower camel case when we're naming variables. Make sure the name is descriptive, refers to some memory location, and the value stored in that memory location can vary or change as the program moves along. Any questions there? Okay. So we're going to dive into some more advanced topics on variable assignment. So the first one is, there's two ways that we can assign a value to a variable. This is the example that we've seen a lot where, the first line is a variable definition where we say what the data type is, we give it a variable name, and then we use an assignment statement using this equals operator, right? So whatever literal we put on the right side gets assigned to the variable on the left side. Can anyone think of the second way we're able to put data into a variable? For those of you who came into Wednesday lab, we did a few examples with it, and at the last Wednesday lecture we did one small example with it. What's another way we can get data into a variable? So one way is using this player equals jaw syntax, like variable equals something, but there's another way that we can store information in a variable. Okay. The second way is using what we call console input, and so that's cin, right? So we ask the user for something, like what is the player's name, and then that value using cin gets stored into player, into the variable player. Does this look familiar? Okay. We briefly covered it in Wednesday's lecture. It was very quick. In lab, you're going to get more practice using cin as another way to store data. The one thing that is like a little bit different between the two is in this assignment statement, we put the variable on the left side of the statement, and in this case, we kind of put it on the right side of the statement. Unfortunately, that's just kind of the C++ syntax, and you have to do it that way. It would have been nice if like both were on the same side, but that's kind of the way it is. So just an important distinction to note there. Okay. The next one, variable initialization. So far, when we assign values using the assignment statement, we've always done it in two lines, right? Where the first line was the variable definition, and then the second line was the assignment statement. However, if you want, and if you know the value at the start of your program, you can combine both of them in the same statement. And this is what we call an initialization statement, where you still need the data type, you still need to create the variable name, but now you can do the equals whatever value. You can merge that into one line. And again, this is just if you know the value at the start. If we're getting input from the user, then it still needs to be done as two separate lines. Like in the cin example here, you can't do like cin string player. Like if you're using cin, it still has to be two separate lines. But if you're using it with the assignment statement with the equal symbol, then you can combine it into one line if you want. Any questions on this one? So I'll encourage you in your labs to try doing it both ways. Like maybe one problem, you do it as two separate lines. Maybe in the next problem, you try combining it in one, just so you get practice doing it both ways. Okay. The next kind of advanced topic, and I know that we're kind of racing through these. It might all mesh together, but again, I want to introduce these so that when you see examples in the textbook or you see other people's code, you've at least seen it once before. And so this slide is saying that if we were defining a lot of different variables in a program, it could take up a lot of space and it could require a lot of typing if we had to list out every variable on its own line. And so C++ allows you to do multiple variable definitions on the same line. The key thing here, though, is it has to be sorted by data type. So you can't do like string name position and like double weight height all in the same line. Like all the strings kind of have to go on its own line, all the doubles have to go on their own line. You can't mix and match different data types on the same line if you choose to do variable definitions like this. Yeah.
So the second one, the one to the right, it does work. If you would format it like that, it just makes two different variables. It makes one that's called name and one that's called position.
Yes, exactly. And they'll both be string variables. And then the second line will create two different variables. One will be weight, one will be height, and they'll both be double variables. So both these pieces of code do the exact same thing. And again, I'll put the slides up after class as well. The final slide we have here is using the variable on both sides of the equals sign. So for this example, I'm actually going to put it into the visualizer so we can see what's happening. Let's go to the visualizer. Okay. So if we're to visualize this, is the code big enough for everyone to see? I'll zoom in one maybe. Okay. So let's kind of step through what's happening, right? Line 5, we're doing it all in one line, kind of as we just learned. Sometimes you can do it in 2 lines, but if we know the value, we can do it in 1. So in the same line, it's creating this new variable, total cost, that's of type double. So that's what's stored here in our blue memory box. And so after this line runs, what value is going to be stored in here? 100. All right. We do the same thing with tax, right? Tax is created, we set it to type double, and we set a value here. So what's going to be populated in this box? 4. Okay. Now is where it gets interesting, because we have total cost on both sides of the equal sign. So what happens? When there's the equal sign, the right side will run first. So right now, like the code is going line by line, top to bottom, but on a given line, it'll end up going in this kind of assignment statement, it will do what's on the right side first. So it will take the value of total cost, which what is it right now? Okay, and it'll take the tax, what value is that right now? Okay, puts it together, 104, and it will update total cost. So if we go to the next line, total cost gets updated to 104. Let's just step back one more time. So we're going to go back in reverse. Again, at this point before line 7 runs, total cost is just 100. It adds 4, 104, and it updates the value of total cost. So what happens to the 100 right now? Yeah, the 100's gone. It's disappeared now, right? Now 104 is the new value for total cost. And so if we were to print out the total cost, we'll get 104 here. Does that make sense? This is actually like a really kind of tricky concept if you break it down. So does anyone have any questions on it? Yeah.
So, and we have to put C out after we do like our math?
The C out is just so that we can print it to the user. So like this is kind of the console that you have in EdStem. Generally, I'm having people print stuff out so that the auto grader can see that you're doing the operations correctly. In a normal program, you might not need to print it out. It depends on what your program is trying to do.
But could the C out, if I was to put C out before?
Oh, okay.
Cost,
Yes.
would that make a difference in my code?
Yes. Let's try that out. So if we put like C out total cost, you're saying like before line 7? Mm-hmm. Okay, yeah. Let's run it and see. Okay. So again, stepping through it, total cost is going to be assigned the value 100. Tax will be assigned 4. And now we're printing out the value of total cost. So what's going to be printed out to the console here? 100, okay? And that's because at that moment when the code is run, total cost is just equal to 100, right? But now what happens? Again, it was 100, we add 4, total cost is 104, so that gets updated in memory. And so now if we print it out, what value is going to be there? Okay. And I didn't like put a new line thing between them, which is why it all ended up printing the same way.
If I was to put C out on line 5.
Oh, okay. Yeah, let's see what happens there. I love these questions. Good to check out. Okay, so yeah, let's put it before we even define total cost, right? Does anyone want to take a guess what will happen here?
It'd be like not defined.
Yeah, so it says like total cost was not declared in the scope. Because again, the code goes line by line. And so at line 5, it has no idea what total cost is because the code hasn't seen it yet. Right? All right.
Wait, I got a question.
Yeah.
I thought a double
Mhm.
was something with a decimal, but that don't got no decimal.
Yes, good question. So when you create it, you don't have to put it by default. When the computer stores it, it will store it with the decimal point if it knows it's double, so it kind of does that conversion for you. I think at this point, the reason why I wanted to store it as a double was it could become a double like value later in the program. So, or wait, let's get rid of this. Yeah, and I think the visualizer doesn't add, like in memory, it is being stored with the decimal point, so this visualizer is not doing a great job representing that. But at this point, 4.5, printed out, and then at this point, it's like able to support the decimal because it was a double. What's interesting is if we were to do this as an int, then the code actually wouldn't work as expected. And I did notice this when some people were doing the lab with like weight, they were storing it as an int. And so when the weight wasn't an int, like their code wasn't working properly. I'll show what happens here. So like 100, 4.5, print out 100. What would we expect total cost to update to here? Yeah, like we would expect total cost to equal 104.5, but it's not able to store the 0.5 because we defined it as an int. So that's why, like, even though at the start it was okay that it was an int, at the start of the program it was fine. Towards the end, it wasn't okay anymore. And like when we print out, we expect the total cost to be 104.5, but it's just printing 104. And so that's why choosing the right data type at the start of your program is super important. All right. Any questions there? Now we're kind of getting into all the little nuances of variables, right? We learned the basics Monday and Wednesday. Now it's kind of putting it all together. So now I'm going to give you all the chance to practice. We're going to do a little debug challenge. First off, does anyone know why it's called debugging when we try to fix problems in code? Yeah, ready?
Because like when it's a problem in code, it's basically a bug. Basically, it's like there's something's wrong with your code, so you gotta debug. You gotta get whatever the bug is out.
Close. Yep. Do you count?
So like, what's the first bug found in like an actual program? Wasn't it like an actual bug?
Yeah. So there is back in the 1940s, the people's computer hardware stuff wasn't working, and they were trying to figure out what the problem was. And then they realized there's a literal moth bug stuck in the computer, and that was messing up operations. And so this famous CS person, Grace Hopper, she was like, wow, we're literally debugging the system, taking out the physical bug. And now that kind of stuck. Now when the code doesn't work, it's not usually because there's a bug in there, but we still call it debugging. Just a fun little tidbit. Okay. Debug challenge 1. I'll give people 30 seconds to think about it. These would be the types of problems that you would see on an exam, right? On the midterm exam, I might have you debug some faulty code. So I really want you to think about it and not just rely on your classmates to give the answer. So the first one here, 3 lines of code. Something's gonna go wrong. I'll give people some time. All right. Does someone want to share? Alpha?
For num apples, the 5 is a string instead of an int.
Yes. Why is it a string here?
The quote second supplementation.
Yes, so we define num apples using int, right? Which means that when we assign a value to num apples, it has to be of type int. But as Alpha mentioned, because we put this 5 in double quotes, this is actually a string. So we're trying to assign a string value to an int variable, and it won't work. And so the fix for it would be get rid of the quotes here and just assign it the numeric value 5. Any questions on that one? Okay. Challenge 2. All right. Anyone want to take a stab? Yeah.
You didn't name the variable, like give it like in front of the, what's the name? The non-apple.
Yeah, like we didn't properly define it, right? Part of why I like showed you all the memory slides was like, you know, if I just showed you the syntax and said you always had to do int num apples like this, it might be harder to remember. But ideally, kind of tying it back to the memory doesn't know like what data type this is. So it doesn't know how much space to store in memory. And so the code won't be able to run. And so exactly as mentioned, we would have to put the data type before we actually assign the value to it. So it would be int num apples. And as we learned in the advanced slide a few slides earlier, you're allowed to do this on the same line if you want, or you could do int num apples in one line and then num apples equals 5 on the next line. But whichever way you do it, you need to specify the data type. Any questions on that one? Okay. Number 3. We'll give people like 10 more seconds to think about it. Okay, Christian?
Okay, so my guess at this would be that Steve is a string and it's set to the variable name. That's my guess of what the problem is.
Okay. Steve is a string set to name. We do have like name as like a string data type though, so that's okay. But thanks for sharing there, Donovan.
String name would have to be its own line because right now it's an error since the doubles and the strings are in the same line.
Yeah. So you know, a few slides back, we learned that you can define multiple variables in the same line, but they can only be of the same data type. So the solution here would be like we can keep height and weight on the same line, but string name would have to be defined on its own line. And if we had any other string variables, we could also define it along with name. But again, each line has to be for its own data type. Any questions there? All right, 2 more debug challenges. Number 4. John?
So you would first have to put height equals 65.5 when the line right below C out, and then below that CN dash height.
Okay. On the right track. So right now, like we're trying to do 2 separate things. Like we learned about the 2 ways you can assign a value. One, you can either do height equals 65.5, or you can do CN funneling into height. You can't do both on the same line. It'll be a syntax error. In this case, so your suggestion was like put height 65.5 on the line above, but I guess we would immediately be overriding that with the CN value. So in this solution, like we're getting input from the user anyway, so we don't need to say what the height is going to be exactly. Like we'll just let the user tell us that information and we'll put it into height. Are there any questions on this one? Okay, final debug challenge. A little bit more code in this one. I'll give people some more time. Does someone want to take a guess at this one? Yeah, right here. Do you have an idea? Yeah.
You never defined what int 1 and int 2 were, so it's going to give you an error because they're not defined.
Cool. So yeah, let's step through it. So at this point, like we've defined num1, num2, and sum. So there's like some storage space in memory, but we haven't actually given a value to any of them. And so like you might think like, oh, like we're giving the value on line 9 here, right? Like we're asking the user and we'll store that in num1, we'll store it in num2. But the order of code really matters. And so at this point, at line 6, there's no value for num1 and num2. And so if we were to run it, sum equals num1 plus num2. Now it like asks for the data. Can't really do input on here. And then it will print out the sum. And it's like using values that aren't defined. What will even happen, this one doesn't do it because of the inputs, but if we put it into a normal code editor, okay, so we run this here. It doesn't even error. It gives like a totally random number. And that's because when it looks at num1 here, like num1 does refer to some piece of memory, and that there will probably already be something in that memory spot, but it will be some gibberish, some random value. And so these errors are actually kind of hard to figure out because the code doesn't error and it doesn't tell you where the problem is. You just kind of have to remember like, oh, num1 just had some random value because we haven't assigned the value we actually want to it. And so, you know, if you're doing arithmetic stuff and you see some crazy number, it probably means that you forgot to set a value somewhere earlier in the code. Yeah, Fred?
So that value could be anything, and whenever we put C in, it just had to be a value there. That's what we're saying. Like it could be anything. Like we could put 0, and then like when they put C in, it's gonna turn to 5.
Yeah, or it's like the order in which we do this line, right? If we put the sum after we have the values, now num1 and num2 will have values. So if we're to run the program again, right, and we're to do 5 and 3, now we'll say the sum is 8. Yeah. Is there another question?
Oh, I was gonna ask, would you just move that line down?
Yep.
Into the
Cool. Yeah, you got it. And that's the solution I have up here in the slide as well. We initially had sum at the top. Now we move it down to the bottom so that num1 and num2 actually have values. Okay, cool. I'm gonna have everyone close their eyes so that you can't be influenced by others, and I want you to give me your honest feedback on, like, this all thumbs up, like this all made a lot of sense, thumbs average, like some parts made sense, and then thumbs down of like it didn't make any sense at all. So everyone close your eyes first, just so you're not influenced, and then put it up so that I can see. Just put up your thumb. Okay. Okay, cool. Everyone can put their thumbs down, open their eyes. Okay. Yeah, so we will have more practice with this on labs as well. But again, this is kind of the difficulty level you can expect to see on exams. Cool. Any questions there before we move on? All right, we're going to hit arithmetic operators. Let me just check on time. All right, sweet. 11:30. All right, so now is where we're actually going to get into building expressions. These are 3 of the base operators that we have in C++, and they look very similar to what you might have seen in a previous math class. If we're pretending A is equal to 5 and B is equal to 2, you can do A plus B, that will equal 7. A minus B is equal to 3. A times B is equal to 10. These should map exactly to if you've taken algebra before, the way those operators work. Are there any questions for this slide? The way you get this like multiplication symbol, it's like the asterisk symbol on your keyboard. So I think for a lot of them it ends up being like Shift 8, but it will be one of those on the top. Okay.
you go back.
Yep. Okay. Int division gets a little bit trickier. So let's start with this first row, right? Result equals 12 divided by 0. From your algebra classes, do you remember what happens if we try to divide by 0? Sandra?
It's an error.
Yeah, so if you were to put it in your calculator, it'd say like invalid, and C++ will give you something similar. If you try to divide by 0, it'll say that there's an error and your code won't run. All right, 12 divided by 3, expected answer is 4, in C++, that will also be 4. Here's where it gets interesting though, 13 divided by 3. So even though the value is stored in a double, if both what we call operands, the 13 and the 3, are both ints, then it's what we call as int division. And so the value will come out as an int. And in this case, if we were to print out result, it would still be 4. Yeah.
So would you have to go 13.0 divided by 3.0?
Yep, I have it coming up in a couple slides, but exactly, if you want the actual value to be stored, you have to make one of these two values a double / like add a decimal point to it.
You just have to do one of them, you don't have to do both?
Yeah, just one of them. Generally good to do both, but just one of them. All right, how about for 14 divided by 3? Do people think it's going to be 4 or 5? In real life, we would expect it to round up. In C++, it'll always just drop whatever's after the decimal. So even if it was like 4.99999, it'll still come out as 4. And then the final one, that one makes sense. That one will just be 5 because it's an exact whole number. Any questions here? John?
So you just put all of them as double?
Yeah, so if you're using numeric literals, make sure you put like 12.0, or you can just store this value as a double. If you're like, double x equals 12 and then did x divided by 3, then that would work too. Okay, and there's a dedicated slide to that. But before we get into that, there is some benefit to C++ dropping the excess number for int division. So in your kind of groups, I want you all to convert 28 inches to feet in inches. There's 12 inches in a foot. And as you're doing it, I want you to also kind of think about like step by step what you're actually doing as you do this calculation to convert from inches to feet in inches. So kind of just in your table rows, we'll discuss for like 2 to 3 minutes. And also share with each other how you're getting there. All right, we'll do 30 more seconds.
There's 12 inches, there's 12 inches in a foot, so you would divide 28 by 12. And it gives you, and if you were doing division, like because it was actually easier in this sense, you don't use it.
Okay, let's bring it back. So first off, what's the answer for this one? Just make sure we're on the same page. 2 feet, how many inches? 4 inches. Okay. So now let's actually step through how we got there. Does someone want to share like the first thing we do? Yeah. Okay, yeah. So kind of what we can, like 12 times what like whole number ends up being less than 28, right? So if x equals 3, then it's like 36, which is too big. X equals 2 is kind of the largest value that gets us there, but it's still less than 28, right? So that's kind of how we got to the 2, was kind of doing that reverse division and multiplication. And then from here, how do we get the 4 inches? Okay, And so putting that in reverse, it's kind of like we're at 28, and we subtract what we've already done, which is 24, to get to 4 inches. And so this calculation is what we kind of call the remainder. And this calculation was what we call the division. And so putting it into a C++ context, we have 2 different operators. One is division, one is modulus. So in int division, we kind of saw on this slide here, it will get like the biggest number, right? 14 divided by 3. So it'll get 4, because that's the biggest number that if you multiply by 3 will still be less than 14, and it just prints that out. Very similar to what we did here in step 2. And so 28 divided by 12, it will be like 2 point something, and it will drop the decimal, and it will just give you the 2, right? The other operator that we have in C++ is called modulus, short form mod. So you'll hear people call the statement as like 68 mod 12, and that uses a percent symbol. So in C++, percent doesn't equal like, 100%. Percent means mod and is used for this calculation. And so it gives us the remainder, kind of how we did the 28 minus 24 to get to 4. That's what this is doing in the background. And so if you use it, it will give you the remainder here. And we would get 2 feet, 4 inches. Yeah, right.
So, say if we were to do double division, would that give the decimal? Or?
Yeah, so if we did decimal division, then it would give us like the 2 point whatever. And the modulus, I don't think will work with doubles, but we can take a look later when we do the live coding. And so that's where, if we actually want the remainder, int division is more useful than double division. We'll be able to do some cool stuff in the homeworks and the labs surrounding mod. So you can do stuff like if you want to tell whether a number is even or odd, you can mod it by 2. And if there's no remainder, like 4 divided by 2, there's no remainder. That's how you know it's even. But if you did 5 divided by 2, there would be a remainder of 1. And so you can do little operations like that to see is a number even or odd. And we'll have other examples in the future labs and homeworks on how to use it. Any questions there? Yeah. John?
Wait, so why is it 68 modular?
Sorry. I'd initially done 68, but all right. Thank you. Good catch. 28 mod 12 will equal 4. Thank you. Okay. And then you all beat me to the punch, but if we want the actual decimal value, then we just have to make sure one of these operands has a decimal point in it. Yeah. Yeah. Okay. So just make sure one of the values is a double. All right, we're going to go on to one final thing, and then I'll have you all try to do some coding, try to find some cool stuff. So we have this piece of code, num1, notice that it's a string 19, num2, string 16. What is the output going to be for this piece of code? We're doing num1 plus num2. Yeah.
1916?
1916. Why is it not 35?
Because they're strings and not integers?
Yes, so if we use this addition operator on strings, you can almost think of it as like if you had like 2 jerseys, right? Like one is like the string 19, one is the string 16. It just merges together the 2 strings of characters. And so this is what a concept we call in C++ called overloading, where the plus symbol does different things based on what the data type is. If the data type is an int, it will numerically add the values together. But if the data types are strings, then it just merges the values together. And so what I'm going to have you all do for the rest of class is just to try like different operations. You can try like string operations, numeric operations. Let me release on the EdStem. So if you have a laptop, take it out. If you don't have a laptop, kind of sit with someone next to you that does have a laptop and work together on different things that you want to try. Let me make it unhidden. Okay. So again, you can go into the EdStem, and on lessons, you should see Lecture 5 activity, operators. Click into that. And again, you can either do it with someone next to you, or if you have your own laptop, you can do it yourself. I've given you some int variables, some double variables, some strings, some bools. And on line 11 and below, just try, you can do cout and just try doing different stuff. So if you were to do like num1 plus num2, just to see what that is, that would give us 8, right? But you can try with different strings. And if you find anything interesting, raise your hand, and I'm going to create kind of a compilation of interesting findings. See what happens if you multiply a string with an int, and different stuff like that. If your code errors, raise your hand. If you find something cool, raise your hand, and we'll compile a list. Again, if you don't have a laptop, just kind of work with the person next to you and share your ideas of what you want them to try as well. All right. Did anyone find what happens if we multiply a string with an int? What happens here? Let's do it times num1.
It says fatal error.
Fatal error. All right, let's go. Okay. The multiplication operator gets confused because you have two different data types. Yep. Why does b1 plus b2 equal 1? Any ideas there? Yeah, so Booleans under the hood are stored as ints, where true is equal to 1 and false is equal to 0. And so it's just doing 1 plus 0 there. What else can we try? So we said some operators, right, you can't combine, like string and ints you can't, but you can do decimals and ints together. And this is kind of the example we saw in the later slide where as long as one of the values is a decimal, your output will end up being a decimal. But if we were to do like num2, 5 divided by 3, it ends up just being 1 without the decimal. Cool. Okay. I'll give people one more minute. We'll bring it back. Yeah. Okay. Final announcements I have. If you came in late and I didn't mark you for attendance, come up after class so that I can mark you. These are what's due coming up. As you see, the assignments are slowly starting to stack up, so it's really important that you stay on top of things. Homework 0, still attend in office hours. I think we have about half the students who've come in so far. Just make sure you hit that by next Wednesday. Homework 1, if you have any questions, you can either come into office hours or you can come into lab to get extra help on that. And then lab 2 is challenging, right? Students who came in on Wednesday, I'd say about half didn't quite finish in the lab time. So it is important that you come into this lab just to get some feedback and help, and it'll help you finish it quicker as well. Yeah. Any questions for me? All right. Yeah. Yeah. Today's lab is at 4 p.m. Yep. And you don't have to be in that lab to attend. You can still come even if you're in the Wednesday or Monday lab. Cool. Yeah. All right. In future days, I'm gonna start marking tardies, so this is like the last pass I'll give on that. Just make sure you come on time for future ones. All right. Name?
John.
John Massey?
Yeah.
Cool. All right.
Public clips.
All right. If you didn't hear, I'll be marking tardies in the future, so just keep in mind. Jamel, okay.
I'll be
Name again? Aaron? All right. Cool. I'll be marking tardies in future weeks, so just keep on top. I got you. All right.
I emailed the registrar office because I think that's what it is. Since I can't add it myself, that's what I need to do. Even though you gave me the permit, I just need them to add it.
Okay.
So by next week, I should be.
Okay. Sounds good.
Also,
Yeah.
so I was trying to do this bonus problem in lab 2, and I just can't figure it out. Like,
Okay.
I got the first one,
Okay.
it went through, and then the second one, it wasn't able to. So when I changed it up to match the second one, it didn't match the first one.
Yeah, okay. So it's probably then what we're outputting needs to be like the variable values. So let's see. Okay, let's run it first.
Okay.
And then let's just do like 120 for the, or let's do a different value from what's there. Maybe like 120. Yep. And we'll do 10. Okay. Total cost after tax is 124. I think that part might be cost 2. Tax plus cost 1. Okay. So the first one I'll say is the tax is 4%, not just like the value 4. So we need to find a way to like convert 4% to decimal, and then we multiply it to the cost and add it to the cost. And then let me just see if there's anything else for the tip 1. Okay, and it would be similar for the tip as well, where we have it as a percent, but we need to convert it to decimal and then multiply that to the updated cost.
I'll probably have to come to lab or something.
Yeah, yeah, and we can talk about it a little bit more there. Yeah.
I might come to lab on Monday.
Okay, that sounds good. I like that you're like trying to tackle the bonus problem. Like we gotta push ourselves, right? So it's good. Yeah.
I still it's not showing.
It's not showing up.
I have to come back for that.
Okay, so yeah, let's try to yeah, lots of four. Okay, so we'll try to address it there. And you like you tried adding it on your end?
I can't do it.
Okay, so maybe the override I need to try to get is like the freshman, like the class requirement override. So I'll try to put that together. I want to check on lab one, if you had any questions. For lab one, I think I saw like you haven't submitted lab one yet, so.
I've been slow trying to get through it because I was sick and so
Okay.
yeah, trying to figure it back out.
Okay.
My day was my, it was either Monday or Wednesday, my first day back, so I'm trying to catch up, but Aaron, because, when you put in
And
20.
if you want to come to like an office hours or lab or anything like that.
Yeah, half of lab today.
Okay. Sounds good. Wait, Troy, really quick. So what's the year? What's that? Is that you're a freshman but not a major?
I'm a freshman and it says like freshman.
And how do you address that? Like
Before when I had to do my class, which I went to my Thursday, my Thursday still hasn't done it. So I'm probably not by his office today.
okay.
So,
Okay. Try to stop by, tell them that like I'm okay with just doing whatever override needs to be done. But I think he might have to remove the role first, and then while you're there with him, try to actually have the